This is my fifth video lesson for Unit 11. In this lesson, we'll be analyzing calculations involving dilution and molality. Go to page 19 in the class packet. Motivation. What variables stay the same when you dilute something? Would the concentration or molarity of the solution stay the same during a dilution? No. Would the volume of the solution stay the same during dilution? No. How about the moles of the solute? Yes, it will stay the same. Learning target. At the end of the lesson, I'll be able to calculate the concentration of a solution after a dilution and compare molality versus molarity. Homework number 5 will be a junipod based off this lesson. Here is a solution. The red particles represent the solute of the solution. We're going to dilute the solution by adding solvent. After diluting the solution, what happens to the following? The amount of solute remained the same, the volume of the solution has increased, and the concentration has decreased. So we know the moles of the solute after dilution must be equal to the moles before the solution. We know molarity is equal to moles of solute over liters of solution. Therefore, moles is equal to molarity times volume. We can plug this into this equation on top, and we get this equation. MA stands for molarity after dilution, VA stands for volume after dilution, and B stands for molarity before dilution, VB stands for volume before dilution. This equation can be found on Table T, is listed under titrations, which we'll cover later on in the course. Let's look at the first question. 53.4 milliliters of 1.5 molar solution of NaCl is on hand, but you need some 0.8 molar solution. How many milliliters of 0.8 molar can you make? The first step is to write down the equation. Do you expect a larger or smaller volume? By reading the question, you see that the concentration of the solution decreased. It went from 1.5 to 0.8, so expecting a larger volume. Next, we plug into the equation. We're solving for VA, which is the volume after dilution, which is 100 milliliters. Notice our prediction was right. We're expecting a larger volume. No, it was not necessary to convert milliliters to liters in the calculations. You will get the same answer if you do. Learning check number 1. If 0.5 liters of 2 molar HCl is diluted with water to a volume of 1 liter, the molarity of the new solution will be what? Pause the video and resume as completed. The answer is choice 1, 1 molar. Here's the work. We're solving for molarity after dilution. Try to do the rest of the questions on page 19 on your own. Pause the video and resume as completed. Here are the answers. For the second half of the lesson, we are going to talk about molality, which measures the amount of moles of solute over kilograms of solvent. This is the equation. Keep in mind, this concept is not on the regions. The unit is molal. The symbol is the lowercase m, or moles over kilogram. Why is molality used over molarity in some cases? If you recall, this graph was from lab number 2. As you can see, when the temperature changes, the density of water is changing because the volume is changing. When the temperature increases, the volume will increase. Therefore, molarity can change with temperature because of the volume. However, molality does not change because mass is unaffected by temperature. Let's look at the first question. We have 1 mole of sucrose that was mixed with 1 liter of water. What would be the molality of the solution? So we got to use the equation. We know the density of water is 1 gram over milliliter, or 1 kilogram over liter. Therefore, we have 1 kilogram of water. So the molality is 1 mole over 1 kilogram, which is 1 molal. Learning check number 2. 160 grams of NaCl is dissolved in 500 milliliters of water. What would be the molality of the solution? Pause the video and resume as completed. The answer is choice 3. In the question, we have 2 moles of NaCl, 116 divided by 58 is 2, 500 milliliters is 0.5 kilograms. Therefore, there's 4 molal. Try to do the rest of the questions on your own. Pause the video and resume once completed. Here are the answers. This concludes the video lesson. Remember to do the JunaPod homework.